Hey. Hello. In the previous talk, we talked about hooks and we talked about Fiverr. Now is the time to talk about the next buzzword, micro-frontend. But before we begin, I want to thank the organizer that gave me the opportunity to speak here. I got this shot while my morning walking. It's so excited to speak in this kind of city that is so excited about the front-end world that they has like a single page application for the city. I'm not sure if you see it. I'd say Wrocław Centrum SPA. So you actually can visit their single page application. But jokes aside, I want to start with a story that happened in my company that I'm still proud of, in WeWork. Who's here know WeWork, the company? Okay, couple of people. WeWork is a company based in New York that basically we have a lot of buildings and we give company a working place, offices and stuff like this. And in the beginning, when we started, we had only a few buildings and a couple of hundred, maybe thousands of members and people to manage. So we started with a very, very simple app. Like before we had any app to manage the companies and the people. The one that actually managed the building used paper and pen and maybe Excel to search for people or know who sits in their building. But we built for them a very, very simple application. How simple? It was just web page with single text box to search. And you're able, as you can see, search for companies or search for members. And then if you click on one of the results, you're able to see a simple page for example, a company. You're able to see what they paid, how much they need to pay in the next month. That's about it. Very, very simple, but they got really, really excited about it. So we really know it's not a big deal. And users, you give them one finger, they want the whole hand, and they started to ask a lot of new features. Hey, if you have the company page, maybe you can also add a button that do something like this. And if I have a member page, maybe I'm able to send them a message, and I want to filter some stuff on the search, etc., etc. So fast forward a couple of years after, the system looks something like this. Okay, this is from the last month or so, and you can see that there are like tons of pages, navigation that you can see, and action that you can do on the building, what happened in the building, whose member has birthday. The search got a lot of features, and we need to build a lot of things throughout the day and throughout the weeks to support those requests. And also on the people side, if we started into 2017 with one team, very small team with only 5 engineers and one product manager that managed the whole product from 0 to 100, we started to get bigger, and a lot of people started touching the code. A lot of people started adding features. A lot of product manager that started to think different about the system. They want something like this. A couple of designers that working on the same system, and things got a bit complicated. And in this point, we had 2 options. Okay, the first option is to keep as usual, business as usual. The dev velocity wasn't that bad. It was affected a bit, but it wasn't that bad. and we could continue as usual and maybe solve things afterward. And we had another option to plan ahead 6 months from now, 1 year from now, and we obviously choose this path. And in this point, I got involved. I didn't present myself. I'm Shem Magnezi. I'm a staff engineer, obviously, at WeWork. And when I got into this discussion and the manager asked me to get involved and to think how to solve and how to better architect the system for future, the first thing I did as a senior engineer is search for Google, obviously. And I started to talk with other people and other companies how they are doing it, start reading some blogs and saw videos. Lucky enough, the micro-frontend buzzword is very popular, and there are tons of blog posts and videos out there. So I was able to learn some stuff. But the most concerned thing when I watch those videos or read these resources is that a lot of companies deal with this, yes, but most of the company somehow build internal tools or their own proprietary solution that really didn't help me, okay? They didn't release it, they built for their own use, so I wasn't able to really leverage those solutions, okay? So I got back to the drawing board and started to think about the problem and how to solve it. So first I saw some common pattern from all those features or systems. First, you started with a POC. Very, very simple app that you just testing some stuff. This POC become a product because someone liked this POC, the POC worked, some users saw it, and think this is worth building. And this is the phase where you actually building a team around this kind of product. But this product is very successful, so more team want to join the effort and building some stuff upon it. And this started to get messy, okay? It becomes some kind of framework, maybe a portal, maybe a system that a lot of teams want to just add a feature or a page or a modal. And if you are not managing it right, it's becoming a mess. A mess that tons of people writing some stuff and no one really can manage it. And here, first, the developer velocity hurt. And second, the system is not really a system. It's a collection of things. So when we want to solve this solution, first we need to do some kind of groundwork, okay? We have maybe a monolith, a very, very huge system that we need to somehow break down, and we need to do some kind of groundwork. First, we need to have some kind of high cohesion. High cohesion, that means that all the features that related, all the things, all the code that actually related, I don't know, to the user login or to the office inspection or to the pricing has to sit in the same place. Maybe it's gonna be the same component, maybe under the same directory, but it need to be grouped together. Next, after we group together similar things, we need to split up things that are not related. So if I have a page of member, for example, but in this page there is the member info and the action for the member and how the member related to the companies and maybe things that, I don't know, sending a message to the member, I need to split those up, okay? To different component, directory, whatever. But this should be split out. Next, I need to circle up every module like this or set of features, okay? It's called limited blast radius. Why? Because if, for example, something wrong with one like piece of the page or one page from the whole app, it shouldn't affect the whole system, okay? If, for example, the service that is sending messages to the users is down, it shouldn't affect the company page, Okay, so if I have one component that somehow has some kind of error, I need to be able to secure it up, and so it will be the only one that will be affected. Next, each component's data should be sit under this component. So it's not like other components should read the internal data of other component. Okay, it should be served under specific API. Okay, this is the next part. If I want to communicate between components, I should have some kind of API to manage it. So if, for example, I'm changing the data scheme behind the scene, the other component shouldn't be affected. Okay? After we have this kind of groundwork, we are able to talk about more solution and framework to actually build those micro frontend. And when I thought about these paradigms or principles, it's really hard not to think about similar or familiar solution that we have. Okay, micro frontend is really similar to microservices. Okay, we had this very, very similar problem in the server world. Okay, once a couple of years ago, everyone had like a monolith Java server that's really hard to manage, that a lot of people and a lot of team contribute to, and a lot of smart people started to break it down to microservice pattern. Okay, so it's really similar, but it's not the same. Why? Because we have our own challenges. We have our own challenges in the front-end world. For example, the first one is the users should feel like it's one and single application. Okay? For me as a user, when I'm using Spotify or Facebook, I don't really need to know that dozens of teams working on this application, and different team build the messaging, and different team build the feed, and others build the events. For me as a user, I want to feel like it's one single application in the UI, in the UX, and etc. So it's really hard. This is something that you just don't need on server side. Next, we have the challenge of the bundling size. In the server side, you can split it up to Go and Java and Node, and each server and each instance will have its own jars or SDK and stuff like this. But in the front-end world, if I'm going to use React and Angular and Vue, each micro-frontend or each application should fetch its own framework, its own bundled JavaScript, and it's going to affect the user experience. So we need somehow to optimize it and to think about it. The third thing, you should be responsive as fast as possible. On the server side, you can use cache, and you can warm up your cache and loading out from database, and maybe you have a couple of instances, so you can get you can take your time while loading or getting out from scratch. But in the front-end world, you need to be very, very quick. And the last thing, at least I felt like this, that in the server side, you have API that already materialized. You have the JSON API, you have protobuf and things like this to communicate between services. But in the front-end world, when we're talking about JavaScript application or mini application, you don't have a protocol in place that everyone supports. So we can think about microservices, but we need to come out with a couple of solutions on our own. But the concept is somehow the same. The overall architecture will look something like this. We have a couple of modules that we need to connect. Upon them, we have the core library, and then we have some kind of framework to stitch those modules together. In the framework, we will have the mechanism for updating modules, maybe some kind of communication if we need between the modules. This will be in the stitching layer. Then we'll have the core library that every module gonna use. For example, if we have user login, we don't need to duplicate it between modules. will have the user session shared between all the modules. Same for UI library, because as we said, we want the user will feel like it's one application. So hopefully all the module will use one component library, so it look the same. And maybe state management or notification and stuff like this will be in the core library that everyone gonna use. It can be big, maybe it can be small, but it depends on your modules. And there is the actual modules that you hopefully can split it out to independent squares. Okay, this is the overall architecture, and we're gonna talk on actual framework. But before we're gonna name the framework, we're gonna list a few. Every solution has its own caveats, so we need to think. We need to ask ourselves what we want to achieve, because again, microservice says a lot of things to different people. Some companies went to microservices to split out the work because there are tons of teams that are working on the same code base, so they want to increase code velocity. So every team will own some kind of model. Other companies went to micro-frontend to upgrade from, for example, Angular to React, but they just can't do it in one commit or in 1 week. It's going to be a long effort. So meanwhile, they're going to use two applications, one in Angular and the next one in React. They're going to live side by side. There are teams or companies that use micro-frontend because they want to turn off or turn on modules on runtime. For example, if I am a company that white label my system, for one instance, I want to turn off the messaging feature, but for another, I want to turn it on. So it's very different, and it depends on your need, and you need to think about it before choosing a solution. And there are a couple of questions that you can can ask yourself. Do I want to support Angular and React and Vue together? Or I say, I know my team, I know my company, everyone gonna use Angular. It's a decision, and it's gonna affect your solution. Do I need to support server-side rendering? It's gonna affect the solution. By the way, even if you chose React, maybe you will need somehow need to save the opportunity to work with React 15 and React 16 and React 17. Okay, it really depends. Or you say everyone gonna use React 16, the newest edition. We are able to do it. It's gonna affect the solution you will choose, and there are a couple of questions that you need to ask before actually choosing some solution. So I talked a lot. Now is the time to actually think some kind of solution and couple of solutions that we have outside for you to use starting from today, not something that someone built and you need to build something like this or wait for them to release it to open source. I split it out to two groups. One of them is for the case that you are able to use the same framework and the same version. Okay, so if one of the teams need to upgrade, all the team need to upgrade together, so you all sit on the same version of Vue. So this is one bucket, and the second bucket is what if I want to have the option to work on Angular and React together side by side. Okay, so let's start from the first solution. The first solution is relatively simple. You take in your modules, your directory, your sort of feature, whatever, and you put it in one NPM module. Okay, NPM module like the module that you use, and you create a dedicated. Most of the time, you're gonna create a dedicated repository for it, but it's not a must. You can use the same repository for all, but I really recommend split it out to different repository. Okay, so every team will own its own NPM module. It will have their own release cycle, bug reporting, features, stuff like this, and they will own it. And it will look something like this. So for example, I am a team with sets of feature. I'm going to declare a couple of components. Maybe I'll declare only one component, so other will be used. It's the same like I'm setting an API in place. Okay, and then I will have my package JSON with all the documentation that needed, who is going to manage it, what is the version, etc. And I probably going to use peer dependencies. Why peer dependencies? Because I don't really want to bundle, for example, React with my NPM package. Okay? If I know that the main system will gonna use React, I want them to bring the bundle.js for React because it weighs a lot. So my module won't be packaged with React and will save some space for us later. And again, need a lot of communication with the main application to know what they have. And if they upgrade, maybe I need to upgrade too. But you can leverage this. And in the main application, it's going to be very easy. You just declare what you're going to use. You're going to fetch it and use it like any other third-party dependency. Okay? Like you use Lodash, like you use React. You just import the things that you need, maybe pass some properties, but use it in your own code. Okay? So a little bit about this solution. It's really help you separate concern from other teams, give actually the responsibility for each team for its own code, its own bugs, and give them their time to choose whether to release the new version. But it might be a little tedious process, okay? Because with every little change that you need to do 2 commits, okay? In one of your package repository and one in the main repository to just update a new version, okay? It's a bit of an hassling. There are a couple of tools that will help you with this, but the basic thing is something like this, and it's not that convenient, especially for components that change rapidly, okay? We use this for very specific package. Most of our team sits in Tel Aviv. We have a couple of teams in New York, but we also have one team in Singapore. And they have a page in our application, and they barely change it. Okay, their changes is, I don't know, once a month when they fix a couple of bugs. And for this, it was classic because this is a very, very remote and not that connected to our teams. It's a bit isolated, so it's good for them. They have their own way to managing stuff. They have their own code styles. They build the package from themselves, and maybe others can use it. And from time to time, we're seeing a PR. We're just upgrading the version. We don't really know what happened behind the scene, good and bad. But it's good for specific use cases. A bit better solution for this is using Lerna. Lerna is a tool that's used by a lot of JavaScript framework out there. Again, it's very, very similar, but it managed under the same repository. Okay, the file structure will look like this. Instead of repository of a couple of repository of NPM modules, we'll have our own packages directory, and each team will have its own directory. You can use code owners with GitHub to manage those stuff, and each module will declare its own package JSON with its dependencies, scripts, stuff like this. And then the learner framework will understand all the package JSON out there, maybe merge some stuff. So if I have a couple of modules that they all use the same Lodash, it will know to fetch it only once. Same for React on other libraries, and it will do it all for you. Okay, it's easier because this will sit under the same repository, so you don't need to know tons of repository. You don't need to commit couple of changes in couple of repository only for one thing. It's very popular, so a lot of systems or repository use it. Babel use it, Create React App use it. So it's very, very mature. It's also will be able to let you manage the versions if you decided to create a new version for one package, but other package will depend on older version of this package. It will know how to fetch it and arrange things accordingly. Okay, it's really strong, especially for this kind of use cases. Okay. Let's jump to the case when we need to somehow mix and match between framework. Maybe it's pure JavaScript, maybe it's Angular, React, Vue, whatever. Okay, we need to somehow mix between those. And the first thing that we have in hand is web components. Who's here familiar with web components? Okay. So web component is actually using the DOM as the API to declare custom components. We'll see an example. Here is the example for my module. Okay, this is how we create my T modules. Oh no. Yeah. So this is the one that I'm actually building. It can be React behind the scene or Angular. Each framework has its own solution to actually create a web component. And all I need to do is to actually register my custom element to the window. This is widely supported by most of the latest browsers, so it is okay. But you need to check with your system if your users use older versions, so maybe you need some kind of polyfills. And in the page, you just use your module. You can pass a property to it, and your main page will look something like this. Okay? You will import all the bundles of your modules, and we will have one place that you combine it together. Cool? And it's completely agnostic to the framework that you use. In the end of the day, I'm just used web component, and behind the scene, maybe Angular creates these web components. So I don't really care. What's great on this solution is you actually use the old plain HTML and JavaScript without really needed support other things. You're completely agnostic to the framework, as we said. And again, it's mostly supported by most of the browser, but you don't really have a shared state. And we're gonna talk a couple of slides. Are we gonna use shared state if needed? Next up is actually building application or wiring application per route. So for each path, I'm gonna use a specific application. It really depends on your application. It's classic for application that have one theme that have its dedicated page. So for example, if I'll take Facebook, for example, not the home page, but the profile page, the messaging page, the events page. Imagine that each theme has its own dedicated page and path. So I just give them the path, and they will render it. How it actually look like? I put here a very stupid and simple solution. So for example, I have a simple Nginx server that get the path from the URL and set some kind of variable to the template engine to know what page I'm going to render. Okay, and in the template page, I just include the one that's right to the variable that I just set. Okay, so if the user go to /order, I'm gonna render the order application that wired to this path. Okay? Again, it's great for systems that build like this. Each dedicated path for each mini application. It's great for server-side rendering. It's actually a server-side rendering. So if you're using it, it will be great for you. But it has some caveats. First, it's just on the server side, but internal navigation in those, so for example, if I have /order with all my application that handle orders, it can be a bit problematic to navigate inside the order. Okay, because it's a new path and I'm not really able to reuse my app. It's not a single page application. It's a couple of applications. And it's not just for whole pages. We'll see how you can mix and match inside one application. So for example, the orders, maybe 2 teams working on the orders page. So I'm also able to split it out to 2 mini applications. So we talked about how to split it out in the server side, but sometimes you need to split it out in the front-end side before you actually fetch it out from the server. So yes, I put iframes here. It's a relatively good solution, though people really hate iframe, and it's relatively old and bad practice. But let's look how it will look like. Again, it's per path, because iframe is for paths, and it's completely isolated. So when I'm visiting a specific part of my application, I know exactly what to fetch. Maybe I'm going to fetch a couple of iframes that sits together under the same page. But again, it's great, for example, if you're building a dashboard. Okay, a dashboard, it's collection of pages that probably not going to interact a lot with each other. Each dashboard will have its own page. You just need to fetch some stuff and you to somehow wrap it up under the same application. So iframe, it's a reasonable solution here. So really not, you don't really do any heavy lifting there. Each and every application work on its own isolated workspace or window. And I can say that there are, since I delivered this talk, I heard about a couple of companies that uses this solution. The most famous is Spotify. Spotify actually uses iframe in the web application to build the front end stuff, because many teams working on the Spotify team, like the player and the suggestions and the profile page, and each one of them has some kind of iframe. Okay. Last thing, and I think this is the simplest solution there. Single SPA. This is single page application. Very weird name. But in the end of the day, this is some kind of framework that give you the right hooks to actually connect your application. I put a very simple code snippet here to actually hook one application. So this is the main page, the main application that wire all the things. First, you need to actually write some kind of configuration to what application I'm going to have, how to load it, what to do when I'm loading it, and connecting things up. Okay. And then on my application, I need to write a couple of functions or entry points. So the framework will know what to do when they mount the application, what to release on unmount, what to fetch on start. So you have the right hooks in place to do this kind of stuff. And they actually have hooks dedicated to React and Angular, and they have examples in their website. But it's not really, from what I heard and the feedback that I got in a couple of blog posts, it's not really production ready. If you have a huge application that used by a lot of people, it might be a little buggy, and it's not gonna handle the workload. It's not fast enough. Okay, it is great for simple application, or maybe for use cases that you want to move from Angular to React, and you just need to somehow connect those two applications. In the meanwhile, after you moving all your code to the new application, but using this for the long run might not be the best choice for you. Okay? So we talked also about communication. In a lot of use cases, I need to somehow share state between modules. I need to call APIs. I need to know that something happened. And we have two options here. One is actually state management. Okay, I have one stage for the whole application, and or maybe a couple of states for different modules, and I need to share them somehow. So here we have MobX and Redux. If you are working on the same framework. I also heard about applications that use Firebase as their state management because it's really fast, but it demands some kind of network to sync things locally. It's a bit weird, but it works and it's pretty cool. I'm not sure how how production ready it is, but it's working and it's relatively fast. The second thing is event-based. Okay, you can use the event management that's supported by JavaScript itself. Dispatch event between modules. You can use maybe ArcJava, ArcJS. Maybe Eventometer is just a wrapper around dispatch event, but you need to somehow come up with some pub/sub mechanism to communicate between modules. Okay, this is more scalable because you don't really need to share state between modules. But event-driven and messaging and pub/sub and things like this, it has its own challenges, and you need to be careful there. Okay, so also communication, we have solutions there. And I started from my own story, what we did in WeWork, and also I already mentioned that we, in some cases, use NPM packages. But in most of the cases, we use Lerna. Lerna is working great for us, but we decided as a group that everyone gonna use the same. For us, it's the same React version, and we needed to do a lot of work to upgrade a lot of code to almost the latest React version. But this work had to be done before we actually went for the Lerna solution. So it was a lot to digest, I guess. 60 or something slides. And I do want you to come out with a couple of points that you're going to remember. First is, in the end of the day, with our current ecosystem and web apps getting bigger and bigger, you're gonna get to this point that you're gonna need to break down your system, okay? And you should think about it earlier as possible. You need to plan for this because you're gonna get there, and you're gonna get there first. There are many options to choose. Not a lot, but there are solutions there. And please don't write your own dedicated solution with tons of JavaScript and buggy things. And if you do, please release it to open source so others will be able to leverage your work or just fix your bugs. But again, there are solutions there before you go in and deep dive to your own to build your own solution, because we are JavaScript developer, and we always think that we have a better solution than what we have out there. And really, in the end of the day, it is all about your teams and how they communicate between them, and the product that you build, because the output of all this solution is just bundle.js. It doesn't really matter if you started from plain old JavaScript or the latest version of Vue. Okay? The code will be almost the same. The challenges is within your teams and the communicate between product managers and designer and how to align those. Okay? This is the biggest challenges that I faced. Think we have also some time for question. Before we take this question, I'm going to publish the slides, because there are very, very good resources there. You can take the picture, or you can find the slides on my blog. I put very minimal code solutions, but here you can find more code and more advanced examples. That's about it.
Okay, questions time.
Have you done anything particular about solving the problem of shared dependencies between applications that are coming from, that are basically making up together a single experience from the customer point of view, but are served and built separately? So how are you avoiding packaging things like React and React DOM separately into every single app, bundle.js, that you're pushing out?
So first of all, it depends on the solution, but in the NPM package, in the NPM version, you have peer dependencies that you just assume that someone gonna fetch this React and it's gonna be available. If you're using Lerna with the right syntax, Lerna gonna manage it.
But you're still talking about ending up with just one bundle.js.
Yeah.
I'm talking about cases where you have multiple different builds that are ending up as separate applications. These separate applications both have dependencies that are shared.
So you can use, if I get the question right, so there are examples that you just can't. You're gonna fetch React bundle every single time. It's gonna make your bundle huge. But there you can use Webpack code splitting. It's gonna be a bit tedious process, and you need to build it accordingly. But outside of this, you don't really have solution there.
You can. You just let's not get into that here.
It might be I don't get your use case.
Next questions? Okay, see. Okay.
So I have a question. What is your strategy for making new modules? I mean, when you are deciding that this chunk of code need to be put in new module, what are the typical criteria for you?
Yeah, this is a good question. Like, how big is a module? How many features? Is only one feature? Is set of features? When think about Conway's law. Conway's law said that your system will look like your like the structure of your teams. So take a look on your teams and build your module accordingly. Don't build one module for a team, but maybe each team will own a couple of modules, but take a look on the teams. So try not to have a couple of teams owning the same module, because you will get to the same problem as before. Think about the team and split it accordingly. Make sense?
Hi, thanks for a nice talk. I wonder, because if I understood correctly, you've chosen monorepo with Lerna instead of the separate NPM packages, and I wonder why. What was your reasoning? I realize it's like a talk on its own, but if you could do it in the future or have a few words about that, that would be great.
Yeah.
Or we can talk later.
A couple of words there. Again, writing, like if I want to change some style and I want to commit to this repository and then commit to this repository, it's very long. And we just have the tools in GitHub to manage not that big repository, okay? Let's get proportional. The monorepo on the server side is millions of components, but on the front end, it's just a couple of thousands modules, and it's manageable.
Okay, thanks.
Any further questions? Last chance? Okay, thank you.
Everyone
that's all.
hungry. Thank you.